go yet?
Yep.
Okay. Okay, so my topic is shapes, as you can see. So the three objectives of my presentation are that we're going to learn why we teach about shapes, what exactly about shapes that we teach, and some ideas for how we can go about teaching about shapes. So shapes falls under the content standard of geometry, and under that there are 4 substandards. The first one is shapes and properties, which is learning about things like angles, numbers of sides, if shapes are regular and irregular, if they're symmetrical or not, and I'm sorry, that's not right. Also perimeter, area, and volume. And then transformation is the second one. That includes symmetry and also slides, flips, and turns, which we probably know as translations, rotations, and reflections. The third is location, which is really just coordinate geometry, locating shapes in a grid. At the younger grades, this is, obviously they don't learn about this yet, but it's more like learning about words, about spatial relationships. So next to, under, below, beside. And the fourth substandard is visualization, which is kind of just being able to recognize shapes in the environment, like the door is a rectangle. Also, learning that there's a relationship between 2D shapes on two-dimensional shapes on a piece of paper and 3D shapes in real life. And also recognizing objects from different perspectives. So one of the most important things about shapes that we read about in the textbook for today is spatial sense. And children need to develop this sense that's an intuition about shapes and the relationships among them. And a lot of people think that spatial sense is innate and you're either born with it or you're not, but really it can be developed and it can be learned. We just have to give children a lot of experiences with shapes. So I'm not sure how to pronounce his name, but Van Healy, okay. Yes. He has this theory of 5 levels of geometric thought that children progress through as they age. And I'll focus only on the first 3 because that's really the levels that we'll be dealing with as elementary teachers. So, level 0 is visualization, and this is kids in grades K through 3 generally. And at this level, kids determine shapes based only on their appearance. Any knowledge of properties is really just informal and not labeled. So for kids at this stage, you have them like sort and classify a bunch of shapes and ask them to put them into categories or ask them to build their own shapes. Really just experiment with shapes. So could anyone venture a guess as to what a student at level 0 might say about this shape? Oh, I just clipped it. This is stressful. Okay.
You can go back again.
Okay. Yeah, so if you were a level 0 thinker, what might you say if I was like, what shape is that? Yeah,
This box.
it's a box. Okay, and why do you say that as a level 0?
Because I would look at it and I would use my prior knowledge and think that looks like a box I saw in my house this morning, and so I would say it's a box and
Okay.
not know the word for it, I guess.
Okay. Yeah, that makes sense. And you said you would say that because of what you saw. You know, you wouldn't say it has 4 sides and they're perpendicular. You would just say this is a square or a box because that's what it looks like. It's not working. Okay, this is a square because it looks like a square. Okay, so then we go on to level 1, which is analysis. And this is where children start to determine shapes based on their properties. So they'll look at this rectangle and say, okay, I know that this is a rectangle because it has 4 sides, the 4 sides are perpendicular, and 2 sets of them are parallel to each other. They can also start to generalize from individual shapes to classes of shapes. So they say, this is a rectangle because of A, B, and C, and all of these are rectangles too because they share the same characteristics as that rectangle. And level 2 is called informal deduction, and this is where logic kind of starts to set in. Properties of shapes can be logically deduced from one another. So, or really properties of any geometric thing. So, you know, you can say, well, if two lines are parallel, then they're not going to intersect. There's an understanding of the concept of intersection and of the concept of parallel lines, and there's a relationship between them. And this is where teachers can start using words like all, some, if, then, kind of to get students to see if they can see relationships between different properties. So if a quadrilateral has 4 right angles and 4 sides of equal length, then it is a square. So the Van Healy levels of thinking have different implications for teaching. They're not age dependent, so it doesn't matter how old a kid is, he might not be at the same level as all the other kids his age. But generally in K through 3, level 0 is where kids are at, and then in upper elementary you'll have a range of levels within your classroom. Axioms, theorems, and definitions shouldn't be introduced, as we've learned a lot, until the end, until kids have developed an understanding of a concept, and then you can label it. So based on a bunch of articles I've read, I've come up with some of the key ideas for how to go about teaching about shapes and geometry. The first is using children's literature, as we had to do in this project. Incorporating drama, like having kids stand up and hold hands and create shapes. You know, so this would be, you know, a circle or an octagon, just having them stand up and move around. Cooperative learning groups for social interaction, and using technology like virtual manipulatives, like I'll show you later, and also even just Microsoft Word. If you just, you know, do an insert shape and then you have a triangle, and you can extend one side of the triangle and see what happens to the opposite angle as you extend the length of them. Probably one of the most popular activities, it seems, is to do sorting activities. So give kids a bunch of shapes like these and say, okay, put these into categories, however you want. And at early levels of thinking, they might do this by color, or they might do it by size. But eventually they'll come up with their own invented descriptions. You know, they might not say this is curved or this has four sides. They'll say things like, oh, this is dented. You know, this looks like a blank. This looks like a blank. And it's important to include regular and irregular polygons in these activities, and different kinds of triangles too. You know, equilateral, isosceles. So they know that a triangle can look like this, it can look like this, and it can look like this, but it's still a triangle. There are also riddles that you can do, you know, to describe a shape and, you know, say, I have 3 sides and 1 obtuse angle. Who am I? Does anyone know? Anyone have a guess? An obtuse triangle? Yes. So, you know, and you have to go through reasoning to think about that, and you can, you know, do a series of these kinds of riddles and talk about them with kids. You know, say, can a triangle have more than 1 obtuse angle? Well, no, it can't. Can it have 3 acute angles? Yes, it can, and discuss that. So there's a bunch of manipulatives that you can use to teach about shapes. We've used pattern blocks in here. There are tangrams, which are, you might remember from elementary school, they're just cuts, you know, a bunch of shapes, and you kind of rearrange them to make them look like objects, like a person or a cat, etc. Then there are also geoboards, which you can have in physical form. They're just boards with pegs in them, and you take a rubber band and kind of stretch them across the pegs to make shapes. And they also